Well, this is an example for one-tailed t-test. Well, in this test, what we do is that we have a simple linear regression model here, and we want to test the hypothesis whether this beta 2 is significantly different from 0. Well, not actually different from 0, it is significantly positive or not. Okay, this is what we want to test. If we wanted to test whether this beta 2 was significantly different from 0, we could have used the two-tailed test, which was beta 2 not equal to 0. But here what we are testing is that beta 2 is greater than 0. Okay, so what you do is that the first step is, of course, you have to set up a null hypothesis, which is your h0 is beta 2 equal to 0 and h1 is beta 2 greater than 0. You have to choose the level of significance. So let's choose that alpha is equal to 5%, or you're choosing at 95% level, you're going to test a hypothesis. So your test statistic is t equals to beta 2 hat minus beta 2 upon standard error of beta 2 hat. Beta 2 hat you will get from running the regression. Okay, you will get some value for beta 2 hat. This beta 2 is this hypothesized value of beta 2, which is equal to 0. And standard error of beta 2 hat, of course, your computer program is going to give you. Say for example, your beta 2 hat is 5.261 and standard error of beta 2 hat is 0.361. So let's find out t. Your t is basically 5.261 minus beta 2, which is equal to 0, divided by 0.361. So well, let us use a calculator here. So it should be 5.261 divided by 0.361, which is equal to 14.574. Okay, let's say 14.574 approximately. So for example, the number of observations in your model is in your data is say 40, and there are two parameters which you have to estimate, beta 1 and beta 2. So the degrees of freedom are n minus 2. So it is distributed with n minus 2 degrees of freedom. So it means that it is distributed with 38 degrees of freedom. So what will you check? You're checking for one-tailed test. You're checking for one-tailed test for 95% level of significance. You can see it here, one-sided test, 95% level of significance. You'll come down this column, and these are your degrees of freedom. You want to look for 38. So it is somewhere between this 38 and this, which is 1.303, I guess. No, it is the side. Okay, 1.684. This one, 1.684. This is the critical value of t. This is t star at 5% level of significance. It is 1.684. So in case if you're sorry, I have written it wrongly. In case if the calculated t is greater than t star, you reject the null hypothesis. Your calculated t is 14.574, which is greater than this critical t star, which is 1.684. So you reject the null hypothesis. You reject the hypothesis that beta 2 is equal to 0. Equal to 0 would mean that beta 2 is insignificant, okay, in this model. So you're rejecting it. You're rejecting it for the alternative, that is, it is significantly greater than 0. Well, what you're trying to do is that you're trying to do this exactly. That is, you have this model and you have this. Okay, so given this, what you are trying to find out is, this is the 5% level of significance. Now this becomes this. So you have found out that this value here, beta 2 hat is distributed. This value is basically in t, it is 1.684. In case if your t statistic will lie somewhere here, then you will reject the null hypothesis, and t statistic is in fact lying here in this region of this curve. Clear? So, well, this is an example of one-tailed t-test. Fine, thanks.